Okay, today we are going to work on some problem on lead codes, search matrix. Let's get started. Search a do two 2D matrix. You are giving an m time integer matrix with the following two properties. Each row is sorted in discrete order. This non-discrete order. The first integer of each row, the first integer of each row is always greater than the last integer of the previous row, and also giving an integer of target. If we found target in the matrix, so we return true, otherwise we return false. You must write a solution O log n, O log m time n time complexity, which I have the other approach, but I have some tricky approach, which I think because of our script give us um, how to say the method which we can do. So in this case, right, they already sorted and then they said like the first integer of each row will greater than the last integer of the previous row. So in this example, the number 10 is always greater than 7, like 23 greater than 20, okay? And then this example, we gave a target at 3, so we found 3 and then we return true. Otherwise, if we gave like 13, we don't have the 13 integer target in our matrix, so it means we return false. Okay, so my brute force approach, we try if they pass or not. Let's try again. So what I'm gonna do, I have matrix fat, right? So we can use fat. It's just that's why I say like tricky one, that's fat. So we fat all array in one array, and then I'm gonna check if uh, matrix fat dot include this is just like is not the time complexity they want us to do because include is gonna go through every element, right? Okay, target. If otherwise, if we found target here, we return true, and then otherwise we return false. Let's try if they pass. Yeah, I did that before. Let's test it. Yeah, okay. Let's get started. Okay, so you see that it's like a passing test, right? So I also have another approach which we want to do. Okay, let's see. In this problem, we can use binary search tree to do like searching array because uh, how to say the benefits of the array or matrix they already give to us. It means they give us as already source, right? So we can use that benefit to work on this solution. So what I'm gonna do here, I'm going to use binary tree to search and by writing like recursive function. So what the approach is, let me see here. We want to do the problem understand, right? So we understand the problem, and then our approach is like we giving the problem is may tempt, tempting the perform a linear search, and then is matrix, but the would be resolved in the time complexity of O time n, right? O complexity O time n square. So that's it like they don't want us to do. So that's why we want to use binary search tree. So what we do instead of searching like linear time, we can do leverage back on the matrix and sort both row and vice and column and vice. So we search by row and search by column using by apply to the binary search to find the target. Okay. The binary search tree, what we do, we can do like search um, a first position at the target within source array and the half of the target. So we can switch them to the half of, we find the mid. value, right? And then we can search left and right, right? So what we're going to do here, because I'm going to use uh, recursive, so I gonna do like have base case. So yeah, we always have to have base case in binary in recursive. Okay, so what I'm gonna do, like let's say if uh our input is empty, right? Um, so let's say if we have no input, or we our input is empty, length equal to 0. And because that matrix, what we're gonna check is like the column, right? So our column will be matrix at index 0 dot length CTHLENTTH. So our approach matrix that length, if there are 0 as well, what we return, I mean we didn't find anything, we return 4. That is our best case, right? And then we're going to create a function, recursive one, with use binary search tree, binary search. So in this case, we're gonna accept left and right, which we're going to create left and right from where, right? Okay, let's see. That's what we're going to call them by returning, okay, sorry, binary search tree. But how do we find left and right? So the rep is set to 0 and right should be, okay. So before we doing that, we have to find the row. So I'm gonna create num row, right? Num row is mean what we're going to do is track to the matrix that length. So that's what we get to be row. How many row, right? LNDTH. Okay. And then we have call row, or num column, right? Num column will be matrix array dot length. Yeah, that's what we want to do here. So what one we doing here? Let me just check my approach here. Okay, we're going to extract the left and right. So what we do here, we have left. Left is start from 0, right? The left, and then right. So what we're going to do, we have to have num of row, num row, uh, com, num num column. And then the column, what we want to attack is the last element at the last row. So we need to subtract by 1. Okay, that's what we get, left and right. Okay, so in our binary search, we also have to have our base case, right? So it's kind of like in while loop, right? So we check if left greater than right. It means we run out of the loop, so we return false if we not found anything. Okay, and and then we need to find the mid position. So mid position, what we're doing here, we're using math. That's 4, and then we want to have left added by right, IGT, and then divided by 2. That's why we find the position of the mid position. And then we want to find the mid value as a pair, mid value. So what we're doing here, we choosing at the matrix, right? Matrix array, and then we want to find the mid position as a pair. So dot 4, and then what we're doing here, we find mid divided by uh, mid position divided by num column. That's what we want to find, the position. And then we also have the value of mid modulo by num column. That's what we get our mid value here. Okay, mid 4, we get to the match. Okay, that is like this position of a column and mid divided by num calls, okay. And then what we're going to check if uh, if the mid value, which we already have here, if the mid value equal to target, if we found it, what we do, we just return true, right? True, okay. And else if mid value, it means if the mid value less than the target, it means they are still not met target. If they are less than the target, mid value less than target. Okay, so here what we do, we return and invoke binary search recursive, and then we want to increment left increment left, right, by one. It means we need to increment mid. It means our mid position when we match is not met the target. So we want to increment left by one until we met, right? So if so, we not do anything with right because we don't want to do a decrement right. So right, we passing the RIGST. Okay, and otherwise, what we do if the mid target still greater than mid value greater than target, so we want to call binary tree again, which we want to do here. Okay, I'm correct. Okay, just not typo. Okay, so the left is not increment, but we want to increment right, subtract, right, decrement right position until we met the position. So what our recursive call here? If they're not found anything, right, they're gonna recursive call again and again. So let me walk through my code here. Okay, we have our 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 function accept matrix as array as our input, matrix array as our input, and then also target number of integer. I create our base case because we going to create binary search tree recursive core. So we need to have base case. Base case is check if matrix is not empty. Uh, if matrix we pass in is empty, right, or nothing inside, we just return false. And then we initialize the num rows which we want to check, like how many matrix length. So matrix dot length is like the length of the input, right? And then we want to have initialized num columns which we want to abstract matrix as zero and length. This means we want to get the length of columns. And then we create binary search tree on line 37, which we pass the position of the left. Left is start at zero, and then the right is start at the last element of the matrix, right? But then because this is not just array, one array, so it's matrix array. So we want to do is like we want to calculate it of the right position by using num rows at the length, right? Times or multiplies by num column. It means this guy, right, on line 30, 20, and then subtract by 1. That's what we get the position of the right position, right index, okay? And then we have our function here, binary search. We accept right and left position. And then we have base case. The base case gonna check if the left greater than the right is mean left position greater than the right, right? So we return false, which means we didn't find anything. And then we initialize the mid position by using mat.for. And then how to find mat.for and the mid position? We use left position added by right position and divided by 2. So we get the mid index. In this case, the mid index, right? And then we have another, we want to find the mid value to compare with the target. So mid value, we're using matrix with array input, and we have the position of mid divided by num column using mat.for. and then at the position index of mid divided by num column. So we made our mid value. And then we have condition here. If mid value is equal to target, if we found it, we return true. Otherwise, if mid value is less than target, it means we need to increment the left until we met the target, right? So we recursive call binary search by adding one to the left target. So our left position, left number will increment until we met the target. And we didn't do anything with the right. Okay, if mid value is less than target, mean we do not find, right? And then otherwise, what we do, we recursive call uh, binary search tree recursive function, and we decrement the right position until we met. And then let's see if my function is work here. Run to see test. We can figure out later. Oh my God, that's not working. Okay, what I'm doing wrong here? 1 second, let me check. It passed the second one. The first one is not passing. So let me figure out what is this wrong. Okay, let me find here. Left and right divided by 2. Mid num column. Mid divided by column. Mid target num col. Oh, okay, sorry. This one not uh we need to mid position subtract by 1. Okay, sorry, that's what I missed here. Not not decrement, right? Because we have to decrement by 1, and then each time the recursive core to our right position or our right index will have changed, right? The decrement decrement by 1. Okay, I think that should be good. Let's try, yeah. Okay, that's all passing and writing my test. Okay, so that's it. It's passing now. Okay, so that's good. I feel like this one is kind of better than this. Oh, yeah. Okay. So let's see here. This is my first one. Yeah, this this was tricky one, right? I'm using fat. I don't think they're gonna accept this solution in interval. Okay, that's it for today. Thank you for watching. I will see you next time. Bye for now.